Welcome to Maths with EJD. In this video, I'll be talking about the probability generative function of the Bernoulli distribution, still under probability generating function as it applies to probability, and that is under the broad topic of generating functions. Okay, so here we're talking about Bernoulli distribution, and in a Bernoulli distribution, for a Bernoulli distribution is actually a special type. A Bernoulli distribution, a Bernoulli distribution is a special type of binomial distribution. It's a special type of binomial distribution with only one trial, Okay. So like n is equal to 1. As a result of that, you have just the random variable takes the value of either 1 or 0 with attached probabilities. So in essence, we have that for a Bernoulli random variable x, a Bernoulli random variable x with with success probability p, with success probability p, as small p, the probability mass function PMF, the probability mass function that is PMF, right? PMF is given as follows. Probability that x is equal to 1 is that's probability of success. Then we have failure, which is value 0. Probability that x is equal to 0, that's more like failure. That's 1 minus p. So that's more like a success and failure situation. So for a Bernoulli random variable x with success probability p, the probability mass function is this, and the probability generating function, the probability generating function and the probability generating function is now if you follow the general definition of probability generating function, right? You know that is more like gx of s, and that is summation from n equal is it n now? I think probability of this from x equals 0 to infinity, I believe, then px s raised to power x. That's the usual thing, right? But in this case, we have just two scenarios like this. So uh just that'll be equal to summation from x equals 0 to 2. We have just two scenarios, 0 and 1. So in fact, to 1, right? 0, 1. So we have px sx. So that means we have p naught s naught plus p1 s1, right? So p naught, of course, p naught is this probability p. This is more like p naught, and this whole thing is P1. So P naught is small p, that's small p. Then we have S naught plus the other P1, that's 1 minus small p, and that is S raised to power 1. So it means that the GXS is simply P, because S naught is 1, plus 1 minus PS, basically. So this is actually the probability density function. I mean, we can open this up, right? It's very possible to open this up. We can have this to be P plus S minus PS, so that we now have so what happens here? PS plus 1 minus P. Okay, this is P naught. Oh yeah, it should be the other way around, right? It should actually be the other way around. So this is So this would actually be P naught and this is P1. Yeah, I think that's the better way to go about it so that we can redo this to make it make more sense. Okay. All right. So we have P naught, S naught, S raised by 0 plus P1, S raised by 1. So P naught is the value when it is when X is 0. So that's actually 1 minus P S raised by 0 plus P1 is small p S raised by 1. So it means we have 1 minus P plus PS. If you like, we can leave it this way, or better still, we can say GXS in this case is simply PS plus 1 minus P. So this is actually the probability generating function for, so we can say, therefore, for a Bernoulli distribution, or a Bernoulli distribution, the probability generating function, PGF, is GXS equals PS plus 1 minus P. PS plus 1 minus P. Okay, this. Now, once we like to drive home the point always, right? So example, we take a worked example now. So we say let X be a Bernoulli. Let it be a Bernoulli random variable with P equals 0.4. Find the PGF, the probability generating function of random variable X. Okay. Now to do that, we just say this is the solution now. So the PGF for a Bernoulli distribution, a Bernoulli distribution with success probability, its success probability P equals 0.4, just like we have in the question, is we already know that GXS is simply PS, right? It's simply PS plus 1 minus P from what we have here. Okay. PS plus 1 minus P. This is PS plus 1 minus P. Okay. So P now is simply 0.4. So we can just build on that. And we know this is so GXS is equal to 0.4 S plus 1 minus 0.4. Okay, so this is equal to 0.4 S plus 0.6. Okay, so with P equals 0.4, we have the PGF, we have the PGF GXS equals 0.4 S plus 0.6. And that is how that goes for Bernoulli, okay? In the next video, I'll be talking about the PGF of the Poisson distribution, which I think talks about what happens between two events. So probability of what happens between two events or something like that. So if you have not subscribed to this channel, you don't want to miss out on that. So do that right away and hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know how helpful this video is for you. Let me also know if there's a topic you'd like me to teach or a problem you'd like me to solve. Then like and share so that more people can have access to this great content. So like, come your way again. Keep doing maths right. Bye.